Yes, so here we go. All to know about Azure Databricks, and it's gonna be like at least like two sessions that we have planned, right? Because we are trying to connect the dots. We have already covered like an introductory topic. Some it had been like some 6 months back, where we have been discussing about what an Azure Databricks is and how you can spin up a cluster. What's the worker node that we have? What's the runtime stack that we have, right? We have been discussing all those things. Excuse me, just give me a minute. Sorry to interrupt. So here, as I said, we have been previously like discussing about the Azure Databricks. We have been speaking of the introductory topics. What's your worker node? What's the runtime cluster that you can spin up? The different types of clusters that you can go up with, and how it promises high availability. Why not Azure Databricks just directly, and why to go with Azure, right? So those were like an introductory stuff that we were discussing on. And Kazum and myself were discussing on how to take it forward, and we have just planned to connect the dots with Event Hub, right? So the Azure Databricks solutions, which can go on with Event Hub here. So here I will be discussing on the Databricks connecting with Event Hub, and you will make sense more about the stream processing solutions with the Event Hubs and Azure Databricks. At this stage, we are going to build on the streaming technologies. Like we will be getting introduced for Azure Databricks for structured streaming and for the Azure Event Hubs. And you will also like understand the concepts of the structured streaming. You will get to know about how to stream the data from a file and how to write that file into a distributed file system along with the Azure Databricks. Hey, I see someone has commented. Am I better now? Am I audible?
Yeah, it's audible only, but sometimes maybe your mic is moving or it's going up and down.
No. It's like a kind of fixed one. I have my earphones raised up. Okay.
Okay,
Well,
okay.
just if it goes down again, right? All right. Thanks. Okay. So before getting on to this, let me sit with a introduction of myself. So I'm here, Abdul Rashid, feroz-khan. You should be. I mean, we should be good with connectivity, but then if you're new for this Dear Azure community, I just want to say hi to you all. I work closely with Kasam Shaikh on the Dear Azure community, and I'm the founder and CEO of Codes as well. We are based out of India and Middle East. We take care of cloud migrations. We are Microsoft partners on Silver app development, app integrations, and data center maintenance. So we work with two core services. One is said to be the migration, setting up SAP migration, setting up IoT cloud environments, and we also go with service sectors like training, right? We provide training and we do consulting as well on Azure certification tracks, customized Azure tracks that we have. And apart from that, we also work with the I've been getting POC level to on project level on consulting part on migrating to Azure. So that's about me. And yes, I do hold a tag of Microsoft MVP on Azure along with Kasam. Kasam is one of our AI MVP as well. And I'm a Microsoft certified trainer too, and being a part of Azure Cloud Advocate program on advising Microsoft on the data center planning and data center maintenance too. I have my email IDs given up here and social connects on which you can reach me out. And there we go. Well, let's start here. So as I said, I take this opportunity of this 1 hour and maybe the next session, which we are planning about by the next week or maybe later. We'll be speaking about how to ingest and process the streaming data at scale with event hubs and the Spark structured streaming in Azure Databricks. We will learn the key features and the uses of structured streaming. So the 1 hour discussion is going to be about implementing a sliding windows, right, to aggregate our chunks of data and applying like watermarking to remove the stale data. We will connect to the event hubs and we will see how to read and write the streams here. Okay. So I don't think this 1 hour would be more than enough. So let's see like exploring Databricks and maybe the next session we will try connecting with the event hubs as well. So here is my complete discussion point, which we are planning for. We will speak about understanding the key features and the uses of the structured streaming, like streaming the data from a file and write it out to a distributed file systems. We will also be using like sliding windows to aggregate our chunks of data rather than the all data that we have. We will see how to apply the watermarking to throw away the stale old data that you do not space to keep. And we will see how to connect to the event hubs with read and write streams here. Okay, so let me start here with understanding the key features and uses of this streaming that we have in structured way. See, with structured streaming using the Apache Spark in Azure Databricks, you can process like millions of data in matter of seconds. The structured streaming is said to be a scalable one, and it's like fault tolerant stream processing engine, which is built on the Spark SQL engine that we have. So this structured streaming is like automatically it goes with the checkpoints where the state data goes with the fault tolerant storage. Let's say, for example, it can be with Azure Blob Storage or it can be with any database file systems that we have. We'll be using Azure Event Hubs here that can receive large amount of data from multiple sources, and thereon we will stream and ingest the prepared data to Azure Data Lake or towards the Azure Blob Storage there. So it's fast. It processes millions of data in matter of seconds. It enables you to do an auto scaling, and it also supports with like streaming automatically where we achieve fault tolerance as well. End of the day, you can query and you can analyze the processed data as it comes by using a structured streaming query and Spark SQL within the notebook environment of your Azure Databricks. So Databricks, let me give you a quick introduction alone. Databricks is like you have it's like a PaaS offering, right? You have the clusters, you have the runtime stack available. You just spin up the cluster and start working with your big data workloads. Okay, we'll be spinning up. So here is my streaming data from a file and writing it out to a distributed file system. And thereon, we will try connecting to the event hubs to read and write the streams. So before getting on, I would like to discuss with an architecture here. So in this architecture, you find a complete solution for structured streaming using Azure Databricks. And we do use like, maybe we can call it from Azure Event Hubs, Cosmos DB, and the data visualization tools as well. Here, in order to read a stream within a notebook in Azure Databricks, you can use the method which is said to be spark session.readStream. And this returns a data stream reader, which is used to configure the stream there. So the first thing that we have here is that you need to understand about the schema that we are going to use. The event hub is going to process, ingest the data from the event hub. It can be a fat data or it can be a trip data that we have. We are going to process that towards the data breaks. And then we need to understand the schema. So every streaming data frame must have a schema. It's like the definition of cloud names and the data types that we give. Some source, such as like a pub and sub source, let's say Kafka and this event hub all, it will define the schema for you, which is the case for this streaming the data from a file. So let me repeat, for a file-based streaming source, the schema must be user-defined for you. And therefore, you need to understand the type of streaming and configurations which are specific to the type of stream. Let's say, for example, it can be from files, it can be from Kafka, it can be with the type of like TCP or IP like that. We also need to like configure the configuration has to be given to the type of stream that we have. Let's say for files, the file type, the path to the files, the max files, those things. And for TCP or IP, the server's address, the port number, okay, those things are set to be represented. And for Kafka, the server's address, port, topics, partitions, all set to be represented here. Now, you can make sense that the files are ingested in the Azure Event Hubs, and it writes a stream to your Event Hub then. And within a notebook of this Azure Databricks, the stream is read. Let me use a pen. Do we have a pen here? Oh, okay. All right. So here, if you could see, we are using from the data source, the neighborhood data that we have. So some source, it's going to define the schema. It's going to write a notebook for the Azure Databricks, and the stream is read from your event hub, and there is where it goes with the transformation, which are made like window aggregates. So the result in this example is that it's stored in a Cosmos DB. The data gets stored in a Cosmos DB for further analysis, where the output of the analysis is visualized in an example of like Power BI, let's say, that this data analysis and the visualization tools that we have. So furthermore, we can also see this query that we used to write. We can configure a file stream. We'll be consuming the files which are written directly. So data schema is where it's recorded at a timestamp, the device string, index long, okay, the model string. So all these things are set to be called. We'll be consuming the files written continuously to a predefined directory. And from there on, we can control like how much data is pulled into Spark at once. And we can also specify the option with max files per trigger here. So here you can see we are returning the data stream and we force it to the processing of one file to be triggered at a time. And we record with, all the streaming data frames are set to be called and the source directory and the file type too. We then have like using a sliding window to aggregate over chunks of data rather than like all data to be called. So this is like when you want to perform aggregations over a stream's entire data set, you might encounter some problems. Let's say some incoming streams will have a definitive start. Conceptually, there's no end to the flow of data as data keeps coming in. And just because there's no end to a stream, the size of the data set grows in a perpetual way. So in order to prevent your Azure Databricks cluster to run out of this resource, when aggregating of the entire in a data set, right? When you aggregate it, you can group the data by windows of time frame, let's say. So here in this example, you can see we are setting up with 5 minutes, or let's say for every hour like that. Here in this example, I'm setting it for 5 minutes of time. Right, the result tables will have the aggregate for 5 minutes of triggers, and the window will overlap, and a single event may be aggregated into multiple windows then. So if we were using a static data frame to produce an aggregate count, we would use group by and the count to be represented here. And then we have like a watermarking. So applying watermarking is that you can go with preventing the data buildup. We can also prevent the log time running the jobs as well. So far we have been discussing about a sliding window and how they could prevent running out of the resource in an Azure Databricks cluster. And here now, it's like in this scenario, when you have many windows, you might encounter some other problems that need to be dealt with. So since every window has to be separately persisted and maintained over time, this aggregated data will build up in the driver nodes with Azure Databricks for you. The end result is that it's going to be like a massive slow down, if not an out of memory error as well. And just therefore, we need to come up with a solution to prevent this slowdown error, or it's like one simple solution which increases the size of our window there. So just that way, we are generating fewer windows. And if the job runs for a long time, we are still building up an unbounded set of windows as well. Let me get on to the lab, right? You will make sense like how we are gonna implement this stream processing solution with Event Hubs and Azure Databricks. Here you can see, let's go with the Azure portal, and I can also find my cluster which I already created. So let's go to the cluster then. Databricks. Okay. Open up this cluster that I have. Launch the workspace. Let's check onto the questions, probably like last 15 minutes, or you can even post it on the chat. We can get this completed. Okay, maybe by the time it gets loaded. Varun, go ahead, please. Varun, you have any questions?
No, actually, I will just come back.
Alright,
So
okay. In case if you have any questions, let's stick towards it. Probably the last 15 minutes, or you can even post it on the chat. Feel free to do that. I will answer it by the time it gets pinned up. Okay, we are good here. And now let me say, I need to go with event hub under Spark structured streaming. Okay, so for this, let's check if I have any clusters here. If we don't have a cluster, let me create a single node cluster. The cluster name, let's say Dear Azure, okay, for example. And it's going to be a single node cluster just for the demo. And that's fine, the runtime version that we have. Okay, terminate, that's fine. Let's create this cluster now. Wait for this. People who are new to this cluster, all you can find this, I mean, the icon, right, which says that it's keep on loading. It means that it's getting spinned up. So let's wait for it. And once when this gets created, I'll try importing the data there. So we are creating a cluster. We need to ingest the data, and we can also invite the team. So ingesting data is like the data source. Maybe I can run write the notebooks, or we can try importing it as well. When this gets spinned up, now you can find the users there. So we can go with your workspace and see we have the users. So here I can invite my, I can pick my notebooks to be imported. Let's say import, and I can call it there. Okay, let me check. I'll try refreshing it once. Something in the background. Could you please send some insights? Hey, see, this is simple. Like, we are trying to create a cluster where we need the nodes. We need to put up like a runtime stack, like a Spark, Scala, right? So Databricks is said to be like one-stop solution where we no need to spin up any of these services, right? We just say like, what's the node that you need, the node type that you need. You need a single node, or you need a cluster group of nodes that we have to come up with, and what kind of Spark version or what kind of Scala versions that you need to use. Those things alone you'll be defining it. And when you say create at the back end, it's going to set up all these things. It's gonna install, right, your Spark, Scala configurations all, and we just have the server machines to be up. That's it. That's called as a Databricks cluster, which is ready available on Azure. It's running on the Azure data center. Eventually, you can also do it. Maybe in traditional days, all we used to work with like Databricks, where we install, right? We need to install like each and every dots that we need. So installing Spark, Scala, setting up the clusters, setting up the infrastructure, and maintaining them is all like a finger cross situation that we had. So now Databricks is helping us a lot, where we spin up. See, this big data cluster itself has been set up with like maybe it would have taken us some 3 or 5 minutes of time, right? This tick mark indicates that this Dear Azure Databricks is now running. All right, Abdul. Okay. Abdul, your voice is okay. All right. Rakesh, I'm sorry, I'm just seeing your message. How do we get today's recorded session? Well, this will be shared on the Dear Azure event channel, right? The YouTube channel that we have. Still, you can keep an eye to be followed up on the Twitter page or the LinkedIn page of Dear Azure, and there you can find an update on this. Well, all right. Let me step forward. See, I will say now that I need to input some notebooks where I can show you how the structured streaming can work. So as I said before, let's go to the workspace, and we shall call it here. I'll say import and go to the URL here. So I have it probably in my GitHub. Okay, and let's try importing it. So let's go to the GitHub URL. Okay, I'll say import them. Can you find this? It has the structured streaming, and we have this. So I said we are going to do like three kind of things.
Yeah,
One
I'm
is said to
here.
be yeah. So now you can see that I have three segments. One is said to be the structured streaming, And the other one is to be like we're gonna come up with listing the active streams, okay, and work with the time windows all. See this command, the very first command that you see here, we are setting up like the classroom setup, right? The classroom setup is that we need all the config files to be added up. So let's run this across, attach towards the cluster, Dear Azure, and say run it. Hi, Kaushik, I'll be sharing the GitHub link before we sign off, right? Let me stick on to these things by the last 15 minutes. I don't want to break the flow. Let me get this completed and your questions and sharing these things, I will do it probably the last 15 minutes, please. Okay. So this is initializing the classroom with the variables and the functions now. So mounting the database from the blob storage towards the cluster that we have. Now we can read the stream. So reading a stream, we are going to use this. I said in the deck, right? We've used the Spark session.read stream, and that will return the data stream reader for you. So this will be having the schema. The files can be like, the stream can be from the type of TCP or IP, or it can be from Kafka. And we're going to come up with the configuration or the specific type of stream to be done. So here is all the schema, and we're coming up with the data frame as well. See, this streaming, I have just given a markdown where it represents like why this streaming is unable to infer or read a schema. If you have enough data, you can infer it. If you don't have enough of data, then we need to go on. We have to set the data frames and put up a time blocks there. Let me try running this. See the data schema, we are going to fetch the data, the timestamp, the device string all. And now we don't have enough of the data, so let's configure the file stream, giving up the maximum files that it can go with triggering. Now make sense here. See, it's recorded with the timestamp, the index, the model all has been given. So in the deck, you should have seen I gave a time interval of like 5 minutes of time. The same concept we are trying to implement here. Here is the data frame. And finally, we can stream the data frame as well. And for the unsupported operations, let's say we need to stream the data frames, which are said to be a static data frame then. See, this we go with a timestamp. We are calling it across here and set up the streaming here. Now let's write the stream. So writing a stream, we have different parameters, and we can go with the data stream writer configuration here. We're gonna call it from the Spark, okay, and see these are the different trigger types that we have. We don't have enough time to speak about all these different trigger types, so I will keep this document to be shared with you people. You can explore with this gal where the different trigger types are available and when to use, okay, and how it can be called with an example too. We will also be setting up a checkpoint. See, the checkpoint is where you set up the location and the point of the path to call the output there. So finally, the output modes. And here we go with some streaming to be done. So we call the work directory. We make sure that our work directory exists. And thereon we go with the subdirectory as well. And followed by that, the name, the query that we have, and specifying the location. So can you find this? It goes on with streaming. The input versus the processing rate, you can find it at the runtime. This is the job that it's running on. Excuse me. See, this is the stream of data that it's running on right now. The job is succeeded, and we find the group on which it has been connected with. We also have a timestamp for the same. Well, now we can go with query processing for the recent progress that we have. Here it is, right? We are trying to query it. We get the run ID, the batch ID that we have, the query planning all to be listed up. And additionally, we are also going to iterate with a list of like active streams that can get it up. So this prints the value for us. And now let's stop the query. Okay, the previous one which is running now, let's say stop the query there. So on top of this, we can also display the function, like the memory that the sync is being used, the output mode that it has been used. So that can be used by displaying the, you come up here with a trigger or stream name, okay, saying it's going to be like my query. So here it's going to be streaming Dear that we have been using. And let's say name to be my stream. Here we go. The device, it's with the data sets from Nexus, the user ID, the user. Okay, we are trying to stream it. We also have the visualizations, the bar or the pie chart, all which we can find it here. So this is how coming up with the data, right? You work with the time data, you call the notebooks then, and we do a structured streaming then. We can then print it. So let me get it. Okay, let's wait. This is still running on Sparking jobs. Any questions for me in the meantime? Okay. All right. Excuse me. All right, there. It's still running. Let's displaying the screen. Okay. It shows the sample values. Let's terminate it, and we should say stream the data that we have here, and say it gives the value for you with the my stream. And let's register it. We can list the tables. So here you find the tables all. Hi, Abdul. I'm sorry to interrupt. As processing time is a little bit more, so how we can increase the performance? Okay, good question. See, when you create a cluster, you had like I created with a single node, right? And the size of the machine, we didn't. I no need any kind of worker node. I'm just doing a demo kind of stuff here. So I went with a single node, but the machine size that you need to use and the mode that we use, you should not go with a single node. You need to define with the other types that we have here. Okay, so that makes sense. Okay, here let's stop all refining streamings we have, and later on we can clean the directory. So this is simply how we can go with your data to be structured with the streaming concepts. Right, we can do the cleanup there. So far we have seen like how we can stream the data from a file, right, and writing it to a distributed file system, all listing the active streams, and we have stopped the active streams as well. Now, okay, we have time. Let's try working with the time windows. Okay, so for the time window, in the deck I was showing you like 5 minutes of time as an example. You can find the same here. Let me go to the workspace and see I have the document for the time windows. They're going to use sliding window to aggregate over the chunks of data rather than the all data to be called up. And then we'll be applying the watermark, okay, to throw the stale old data, and we'll plot the live graphs as well using the display there. Let's do the classroom setup again, attaching the cluster. So we're going to stream the aggregations. Let's say, for example, from a traffic signal, or it can be like IoT cars that has been connected with. So in those cases, we can use this. This is the example which we were discussing about the sliding window, which goes with 5 minutes of time interval. And we also need to understand about the event time and the receipt time. Event time is said to be where the event occurs in the real-time metrics. And the receipt time is that it's about the structured streaming where we come up with the receipt time. Shall try running it again. So here we are getting the window streaming example where we have called the data from your JSON file which has been located with. There on, we can define the schema, okay, the schema for streaming the content. Rakesh, IoT workloads. Okay, can I park this question? I will set back to this probably in the 10 minutes. Okay, let me complete this flow. So here we are defining the streaming data frame as well. So what are the inputs that we have called? We can call it. We can stream with the data frame, and let's view the results. See, here it's streaming the jobs. Let's wait. Okay, see, this is displaying the query. Okay, the action that it has taken, state, and the count. Okay, the time. So here we can put up the performance consideration with the Spark jobs, how many it's running all. We can group it and we can see what's the cost for the delay that we had. So here we say shuffle the patterns and display the same. Spark jobs getting streamed. I can list up the jobs that it's running on. See, these are the jobs that we have. Excuse me. Okay, this displays with the I mean the job when it got started with, when it's closed, okay, and the number of event jobs that it has been streaming all. And then terminate it and just say terminate. And this is a document for you to make sense about the problems that we have with generating many windows. Okay, we are generating a window for every like 1 hour with every day, and we have to make it like separately persisted to, right? And furthermore, we also need to go on with the build up to be given on. And finally, we can refine the previous example, calling the watermark for the same. The Windows start time, the action that we have, and the count as well. This streams the data. It says like the action and when it gets closed as such. See here, it's like more specific. We are gonna get the data to be received with 2 hours past the watermark will be dropped, and the data received within 2 hours is not gonna be dropped at all at real time. Now, how we are going to manage the workloads with IoT? Let's connect the dots, right? What in case if your IoT data is going to give up, let's say some self-driving auto cars is going to give up a data which is like 2 hours later, saying there was a traffic or there was an accident which was met at location A from car A1B to car A2B, right? If it's a delay of like 2 hours or 3 hours, let's say the data has to be dropped, right? We don't need any kind of like unstructured or like worrying data which is said to be considered, okay, with the late metrics then. So in those cases, we can use this particular part. And thereon, I would say I need to stop all the streams. And we can then move up. Okay, we will see like using the structured streaming with the Azure Event Hub. All right, here. So here in the portal, you can see like we'll be having structured streaming with Azure Event Hubs. Okay, it's 919. Okay, we have time, not a problem. Let me go for this data engineering resource group that I have. And you should find the event hub namespace. Okay, let's open this and we will try creating a new event hub. Here, let me give a name. Point as Databricks. So let's say demo web event hub. Partition count, let's say 2. Message retention will be 1. Let's create it. See, this event hub has been created. It says about the live metrics with the request and the messages all. There I can go with the shared access key, call the root, manage shared access, and take a note of this connection string, primary key that we have. Let me put it on my notes. Right. So here it is. Now let's try running the notebook. So here we go. Move to the workspace. Users. See, we are streaming with the event hubs. Let me open the streaming with the event hub. And let's attach the cluster. Excuse me. So we have attached the cluster there. So here it says like we need to install, right? And we need to come up with the event hubs to be read with a stream mode. So to do this, I can go up, give me a minute. I have my Databricks solution. Just hold on, please. Yes, so let's go to the compute. And we have it here. Let's go to the libraries. And in the libraries, let's say install new. We'll say Maven to be added up. Coordinates, we have it here. Okay. Maven coordinates. Okay. Let's search the packages. Let's search for this now. Excuse me. It's loading. We need Maven to run this. Okay, so let's install the libraries. This is going to be on the Databricks cluster. No results. Maven Central. Maven. Let's paste this. Hopefully it should get installed. Let's see. It's on the Azure package. Okay, there's a question. Chat, what's that? Rakesh, does it build data by pipelines for different data ingestion methods? It's recommended. It does on its own as well if you have some runbooks which has been written up. But as an architect, maybe I would say you need to define different pipelines for different data ingestion methods, right? Because you have the data types which can be different, right? One can be from TCP or IP, one can be like a structured data that we have. So you need to define with different pipelines. It can do on its own. We have templates available. We have runbooks available. As an architect, you also need to make sure that we go with the individual pipelines we got. Is that okay, Rakesh? Right. So this has been installed now. Okay. And we shall now go ahead. Let's run the code. Okay. It's set to be on the compute part. Go to the workspace, stream with event tabs. Let's try opening tab here. And here I've tried running this. So this library allows the Python to stream the content. It collects all the Azure event tabs. Let's set up the classroom then. Attaching the cluster. Okay, see, this has been called up. Now let's run the setup. So then here is where we are going to call up the event type connection strings, the one which we copied here. Okay. So copy this and keep it updated. Don't run it, just keep it updated. So this sets up a local streaming file, okay, to which writes to the event hub. Well, okay. Now let's try connecting with the event hub. So you call the Python, you connect with the event hub. Right. Let's write the streaming data to produce the stream thing. Excuse me. Okay, it's streaming the job now. Okay, let's try then importing the JSON files all, and we'll put up the event hub config and read the data to. So it reads the data, and here we go with the values to be called up. And thereon we can display it. See, we get the data to be listed up here. So the device, the city, the country, okay, the timestamp that we have. And we said that if it's older than 2 hours, it has to get dropped off by its own. Next, let's pass the JSON payloads. And let's pass the data to. And finally, we are going to call the schema all. So here's the flat schema, which represents with the timing. And the streaming goes on with the event hub. Now let's check the event hub. Click on overview. You can find the metrics. See the Databricks demo event hub and the message retention, the telemetrics just been added up, and the partition count. So this is how the Databricks can be used with the event hub part. Okay, and finally you can stop all the streaming activities that we have here. At top of this, we also have like the event hub which can be executed. Let's say if you have a group of cluster nodes, all there also we can try doing the same. Okay. All right. So that's about like event hub and having your Databricks to be connected with, streaming the data, giving up a window sliding all with the time interval that we have. Please let me know if you have any questions. I have another like 10 minutes to stick onto your questions that you have. Okay, Rakesh, go ahead, please.
Hello.
Yeah, Rakesh, go ahead.
Yeah. How does this Databricks is different from MLflow? MLflow has inbuilt Databricks. It does the all event management, cleaning up the data sets and streaming the data and building to the pipelines as well, right?
Yes. So there's a managed ML flow that we have. It's an again an open source that we have that's developed by Databricks itself. It can go with like all like the security and scaling to be taken care. Again, the
Yes.
experiment tracking, all those things can be managed with the ML flow. I just want to understand like what's your question exactly? Having Databricks with ML flow.
So this the data breaks is also, I mean, it's a separate tool for data injection method. We can build a pipeline, right?
Yeah, I don't say it's a separate tool. It's going to be like one of a task that you can execute by connecting the pipelines. But apart from that, you also have other tasks like you can do the model management, you can deploy the models, right? We can keep a track of it. We can call the REST APIs all. You can set a model versioning for ML flow model registry. So it's all like different types of tasks that we can achieve. It's not like a separate service. It all comes under the Databricks only.
Yeah, it also comes under database. Yeah. Okay. Okay. Fine. Fine. Thank you.
All right.
And hello.
Yeah, I'm there.
How to handle this IoT workloads? Do you have any idea?
Of course, yeah. See, IoT workloads is ideally managed with service like we have Azure IoT Hub that's available, IoT Shoot, which gives the templates all, and they have the reference architectures. Let's say, for example, to connect with a shipment container to get the track of done, connecting with the Power BI or connecting with the Tableau, keeping the event track to be done, or you need to do this model management or using Azure Event Hub using Azure Databricks. So those templates are also ready available with the reference architecture. The service that you need to use is you go with IoT Central, you go with IoT Shoot. Okay, there we can manage the IoT workloads. If you want to connect with Databricks, yes, you can do it. But what I would say is that just see if you have like more workloads that you have, right? If not, Databricks is going to be a costly solution. Instead, you can just go with Event Hub. You can use ADF all to manage the data, right? Why you need to come with Databricks?
Exactly. Yeah. Yeah, sure. Thanks.
Uh,
Thanks. Good session.
Thank you very much. Hi, Kaushik. Will us be tagged with this recording post-procession? Uh, Tagging is like finger crossed because we have a violation, right? I don't think, I mean, everyone would be comfortable with. So it gets posted. You can follow the YouTube channel. That should be a simplest way. You can just follow like the YouTube channel and you can get an update there, or you can even find it on the LinkedIn or with the Twitter updates that Dear Azure used to give us. Hi, Kaushik. Can you show the implementation or creation of three-layered Delta Lake? Bro? Yes, but that will be like altogether a different task. We will definitely plan for a session there, right? We will see how we can integrate and how we can set up with this Delta Lake and Databricks. It's a hot topic that we had right from the Microsoft Ignite event. We will definitely work on it, but maybe we will do it on the next session, right? We will plan for a session to speak about how Azure Databricks and Delta Lake is enabled. We will keep this considered, Kaushik. Okay. Finally, the GitHub link that we have for this. Let me keep it shared. You can collect the data from here. Yes, here you go. It comes with a certification as well with DP203, so you can even keep it followed there. Any other questions for me? All right, so hopefully Kasam should be having other sessions. Yeah, see, here's an update from him. This guy is like super active, always hosting some sessions and giving some hot updates for us. So the next session from our Rockstar is going to be with Azure Data Factory for Cloud Professionals, which is on 26th March at 10 a.m. as per IST. So you can keep following. Oh, yeah, there's an update from Kasam as well. So the next session is on 26th March. He keeps buzzing up with events, event management, and keeping the updates of Microsoft Azure to be rolled out. I really appreciate that. So the next session is on again ADF. on the big data family itself. So for the cloud professionals, it's going to be at 10 a.m. on 26th March as per IST. And yeah, there's the YouTube link that it goes. And Kaushik, yeah, it's for you.